All right, guys, so this is lab 1.1 through 1.6. It's going to be a series of 6 different labs. So what you guys are going to do, if you're virtual, you're just going to go through and watch these videos, and you're going to make notes in your student sheet in your science notebook based on the setup that you have attached on Schoology. So make sure you set your notebook up prior to starting. Side note also, on your screen here, you're going to see the lab sheets. So when you are looking at these are not the numbers that are in your notebook. The student sheets are attached on every single video as we progress through the presentation. So your numbers go off of the student sheets. This is just the lab sheets that we're going to go over real quick before we get started. All right, so the first lab is the hand warmer. On this, you're going to rub your hands together and make note of the temperature readings as you rub your hands together, and then when you stop rubbing your hands together. And there's a few additional questions you're going to answer as you go through there. All right, the next one is constructing a graph. That one's pretty straightforward. You're going to use the data that is here, and you're going to construct a bar graph. So go along with the video. It's pretty straightforward. All right, the next one is called rolling around. So on this one, there's going to be a steel ball placed inside of a roll of masking tape. You're going to make observations as the video progresses. So just roll with that. That was a little pun there if you didn't miss it. All right, the next one is the puck launcher. So this is already set up on your tables. Again, if you're virtual, just watch along with the video. So on this one, you're going to make note of the motion of this connects wheel when we pull a rubber band back 2 centimeters and when we pull it back 4 centimeters, and you're going to describe the differences between how the puck traveled. 1.5 is down the ramp. So you're going to make observations on how the car behaves when you release it from the top versus how you release it from the bottom. So position 1 is at the top, position 2 is at the bottom. On 1.6, this is the suspended bar. You're going to be making notes what happens when you bring bar 1 close to the suspended bar. You're going to flip the bar 1 around and use the other side and see what happens there. Again, you're making observations based on your student sheet. So roll through these. If you get stuck, let me know. All right, guys, so this is station 1.1 or inquiry 1.1 of the hand warmer. Make sure you are answering these questions in your science notebook as the video rolls. All right, guys, so this is your video for 1.1, the hand warmer. So on this, you are going to need 2 materials, your hands and a thermometer. The one that they sent us that had the little metal probe that you'd stick in between your hands and hold it and rub, that one doesn't work. So we have a couple of these. They work a couple different ways. So if you have trouble, let me know. Otherwise, I will show you in class. Those of you that are doing this in class. Otherwise, you people on the video, you're just making observations as we talk. All right, so make sure you're following along the student sheet. It tells you where you need to make observations and what you need to write down. So that's to the left of this handout, and it will be for the rest of the video. So the student sheet that tells you what the questions are that go in your notebook, those are on the left of the video. All right, so the procedure, it tells us, number 1, to put the digital thermometer shaft between the palms of our hand for 1 minute and observe the temperature reading. Well, I have contactless, so there's my temperature reading before we start. All right, so in the procedure sheet says, leaving the thermometer between your hand, rub your hands together for a short time. Observe the thermometer as you do this. Stop rubbing your hands and describe what happens to the temperature. All right, so we'll rub our hands together for a minute, and you can do this at home, and you can feel what you're going to see. So the data you'll be taking at home will be qualitative, meaning descriptions. All right, so let's look and see what happened to the temperature. Notice what happened there. If you forgot what the first number was, go back and look at it. All right, let's continue. A little more. That one didn't go up at all. That was a better jump. So as I rub my hands together more and more, make note of what happens to the temperature. Even if the numbers don't keep going up every time, go back to that initial number of 97.4. Okay, so stop rubbing your hands and describe what happens to the temperature. So I haven't rubbed my hands. So from those high numbers, what happened? So we'll just keep taking readings. All right, so as I waited after I stopped rubbing my hands, what happened to the temperature? I mean, you can test this at home. Rub your hands together for a moment, like 30 seconds. Feel how warm it gets. And then what happens when you stop rubbing your hands and you just let your hands sit. All right, so that's number 2 for the procedure. All right, procedure step 3. Write down another example of how you can produce heat. Something that you can do that gets hot. And procedure number 4, each student is to perform 1 and 2 if there's time. So again, that was literally rubbing your hands together and taking a temperature reading. If you're at home, you can just get the data from this video. All right, guys, so this is inquiry 1.2, constructing a graph. Sorry if there's a little bit of wind noise. I'm outside and it's getting kind of breezy. So you guys will be constructing a graph going along with the video. So things you need to make sure you pay attention to. All graphs have a title. You'll normally get that from the table or the data that you get. So that's where that comes from. Your axes also need a title. So I kind of drew a line where you're going to be putting your titles. So this is your y-axis, this is your x-axis. If you don't have that memorized, that will be something you need to make note of. So pay attention. You guys will be doing the 3rd bar of the graph on your own. So make sure you pay attention with the first 2 steps. All right, guys. So this is your activity for 1.2, constructing a graph. So on this activity, you're given a ruler, which is in centimeters. It also has inches on the other side, but we're going to be using the centimeter side. Well, you won't be using it for this part of the lab. But anyway, your ruler is going to be for drawing your chart or your little graph here, and your chart if you need something for the straight edges. So you're going to be graphing the information presented here. So let's go over what we're going to be doing. So procedure. Number 1, A bowling ball was released and the distance it rolled was measured at the end of 5, 10, and 15 seconds. That gives us our data from our chart. Using the measurements in Table 1, draw a graph on Student Sheet 1, which is your notebook, which you already should have set up at this point. So we're going to take the information from the chart and set up our graph. All right, so number 1, let's just go with the title. So notice it gives us a title here. We're just going to go with what it gives us. So our title for the graph is going to be distance the bowling ball travels over time. The bowling ball traveled over time. You get this to fit on one line, that's fine. I'm just trying to keep it compact. All right, so we have 2 columns. We have time and we have distance. So As a rule of thumb, anytime you're given time, we're gonna put it on the x-axis. So we're gonna put time on the x-axis and its units are in seconds. That leaves us with distance to go on the y-axis. All right, so let's see. The time is already broken up into spaced out units that have equal spacing, so we'll do the same thing. We'll just keep them 5, 10, and 15 seconds. And the little S stands for seconds. All right. And then we've got distance. It's broken up at 15, 25, and 30. All right. So we've got to think of a spacing for these numbers or a scale to set these up. So it goes from 15 to 30. So as we go forward, you guys will set these up. But for the first one, I'll kind of walk you through it. All right, so 15 really wouldn't be good because the spacing would be kind of hard to estimate for 25 where you'd be able to see it. So a good number would be 10 because 5 is in between 10. So about halfway in between the marks would be 5. So let's do this. So 10, 20, and 30. So 5 would be here, 15 would be here, 25 would be here. So that's very, very easy to show. All right, so the type of graph we're making for this is a bar graph. So that means we're gonna have little bars to go up how far it went. All right, so the first one, at 5 seconds, the distance was 15 meters. So here's about 15. So we'll just make us a nice little bar. And then we'll just kind of shade it in. All right, so that's our first one. Our next one is at 10 seconds, it went 25. So 25 is about right there. And again, we're gonna color it in. All right, our last one is 15 seconds. The height was 30 meters. All right, so let's not forget meters up here. All right, so again, the x-axis was time. The y-axis was distance, which was in meters. So everyone doing this virtually, we did the first two together. Now you graph at 15 seconds, it went 30 meters. All right, pause the video for a moment and complete that. All right, so now that we're back, what does the graph show about the ball's motion? So this is one of those times you're gonna have to be descriptive and talk about, as time happened, what happened to the distance. Look at your chart, look at your graph, and write a description of what happened as time went on to the distance of the ball. All right, so make sure you have everything we did here in our notebook. This should be drawn in your notebook, and you should finish the 15-second column and make sure you've answered number 3. All right, guys, see you in the next video for 1.3. All right, guys, so this is activity 1.3, rolling around. You are looking at this part of your student sheet, the first 2 questions. This is pertaining to 1.3, so make these observations as we follow the procedure. All right, guys, so this is activity 1.3 or lesson 1.3, rolling around. So on this in your notebook, just so you are aware, this is number 1, which is labeled as number 2 on this procedure sheet, and then this would be number 2. So in your notebook, 1 goes here, 2 goes here. So just make note of that, but keep the numbers the same in the notebook. That way it matches mine and it'll line up with the test. All right, so for this lab, you have 2 items, a steel ball and a masking tape roll. So the procedure, it tells us to place the steel ball inside the roll of tape. Then use your hand to move the roll of tape in a circular motion to make the ball move around the inside of the tape. It's like this. When the ball is rolling steadily inside the loop, quickly lift up the roll of tape and watch how the ball moves. Are we watching? All right, let's do it again. All right. So, what happened when I lifted up the roll of tape? You're making observations here. All right, so it's gone. I gotta go get it in a minute. So let's go answer some questions. Do you think there are any forces acting on the ball when it is rolling inside the tape? Why or why not? Pause the video, answer the question. All right, number 3, describe the motion of the ball after the roll of tape is lifted. Do you think there are any forces acting on the ball after the roll of tape is lifted? Why or why not? Pause the video, answer your question. All right, guys, so just make sure you take a moment and have those questions answered, and we will be debriefing these in class. If you have questions, though, in your virtual, just let me know. See you in activity 1.4. All right, guys, so this is inquiry 1.4, the puck launcher. So on your student sheet, these are the questions you need to be addressing, and we'll be following this procedure as we complete this inquiry. So make sure you're making your observations and completing your student notebook. All right, guys, this is activity 1.4 or lesson 1.4, the puck launcher. So on this, you have a little pegboard contraption with a slingshot attached. We'll show you that in a moment. Everything's pre-assembled for you. Your meter stick is going to be used to measure how far it goes, and you'll be launching this connects wheel with a rubber band. So what we're going to do, let's just go through the procedure section. We'll go through, do it, and you can take your data for your notebook. So, number 1, put the puck in the center of the rubber band against as it's shown below. So that's referring to the bottom of the sheet that you can't quite see. So that's the way you're going to set it up to do the experiment. All right, pull the puck back about 2 centimeters and release the puck. Describe the puck's motion. So let's do that real quick. Well, let's just finish going through it. Number 2, put the puck against the rubber band, pull it back about 4 centimeters and release the puck. So we're going to double the distance we pull the rubber band back. And you're going to make a note under number 2 and describe the motion. Number 3, what forces acted on the puck each time it was released? So you're going to write what you think there. Number 4, describe how the puck's motion is different and how it is the same in the 2 trials. So 2 statements. Number 1, how they're different, and then the second statement, how it's the same. Number 5, give an example of a force that acts on an object. What is the force's effect? All right, so let's go through this real quick. All right. So here's our little setup. I have it all set up here. All right. So we're going to line it up. Here's 2 centimeters. So I'm going to pull it back to where it begins. So this is about 2 centimeters. All right. How far did it go? Move the camera so you can see. It went about that far. That far being about 62 centimeters. So we made it to about there, 62 centimeters. That was for 2 centimeters on the rubber band. All right, so let's repeat that experiment looking with that at 4 centimeters. All right, again, I'm gonna set this up so you can see the launch. I'll set this to 4 centimeters. So when I pulled it back 2 centimeters, it went 60 centimeters. So let's see how far it goes this time. Well, to answer your question, this time we went the full length of the ruler, which was 100 centimeters. We went off the table and we came this far. If you want to see how far that is, 1, 2, 3, 4, 5, 6 feet. It landed in this block and went another 3 blocks. So it went in the air 6 feet from our table. All right, so let's go back and answer the questions. So we've shot our 2. Shots that we're going to shoot. Now let's go back and answer the questions. So, describe the puck's motion when I shot it with 2 centimeters. Describe it when I shot it with 4 centimeters. Number 3, what were the forces acting on it each time it was released? Give your best answer there. And again, answer 4 and answer 5. All right, good luck, guys. I'll see you in 1.5. All right, guys, so this is activity 1.5, down the ramp. So again, make sure you're answering your questions in your student notebook for these questions, and we'll be following the procedure sheet. It'll be on the screen. It'll pop up every now and then, but for the most part, if you're virtual, you're just making observations. You guys in class, you have access to this procedure sheet. All right, guys, so this is 1.5, rolling down the ramp. So I've already got everything built for you. We're going to be using this ramp that you see here and this car built out of Connects pieces for the purposes of this activity. So, procedure. Put your car on the ramp's high end, position 1, and let it go. That's that top piece of masking tape you see up there. So it'd be up here. This would be position 1. All right, and let it go. So for number 1, you're going to be describing the car's motion once you let it go. So number 2, on the number 1, you let it go. Number 2, you're going to describe the car's motion. You'll be doing that in number 1 there in your notebook. Number 3, put the car farther down the little ramp in position 2. That's the one right there. Number 4, describe the car's motion. You'll do that in number 2, 1.5. Then number 5 there, compare the motions of the 2 cars. Explain why they are different. So this is what you think here. All right, so number 1, let's go with putting it at the top. So it's at position 1, I'm gonna let it go. So let's do it one more time. Maybe it'll stay on the track. If not, just describe the motion. That one made it just about all the way. All right, so pause the video and fill in your answer for number 1, describing the car's motion when you let it go for position 1 on the high end. All right, so now let's do position 2. All right, so describe the car's motion for number 2 there when I let it go at the lower ramp. All right, pause the video and do that. All right, and then the last one was compare the motion of the 2 cars. That's gonna go in blank 3. Explain why they are different. All right, guys, so that'll wrap up 1.5. I'll see you in 1.6. All right, guys, so 1.6 is the suspended bar. Again, here are your observations you need to be making in your science notebook. If you missed some of these, you need to go back and make sure you've made all of these observations. We're going to talk about each different inquiry in a different lab. So follow along with the video for this next one and enjoy. All right, guys, so this is 1.6, the suspended bar. So on this activity, we're gonna be doing a few things. Everything's set up for you here. Give me a second, I'll show you the setup. This is how everything's set up. We have a ring stand with a pegboard attached to it, with a bar hung from a string, and we're gonna do some stuff. And you're gonna make some observations in your notebook. So, let's get rolling. All right, so just follow along with me on your handout. So, procedure number 1, bring bar 1 near the suspended bar. So, bar 1 is this second bar that I have. So, let's watch what happens when I bring bar 1 near the suspended bar. All right, make note of what happens there. Turn bar 1 around and bring it near the suspended bar. Stabilize it again. Watch what happens when I'm gonna let it stabilize. All right, watch what happens. What happened there? Stop it. Oh, look. All right, make note of what happens. Number 3, take the compass on the table and place it near the suspended bar. All right, look what happens when I move it around the bar. So I can also sit it on the table here, and I can give you a little bit better view with the compass not moving. So notice what happens when I bring the bar near the compass and I move it around it. All right, number 4, what forces are acting? Look, back to number 3. Make your observation. What happens to the needle when I move the bar around it? Number 4, what forces are acting here? So for here, just say what you think. Right or wrong answers it's not necessarily incorrect, even if it's wrong. The whole point of this is to start thinking. Number 5, can you make the suspended bar spin without touching it? Let's test that. So without touching it, how can we make it spin? All right, so I'll even make it go the other way. And you can also make it do the other thing. Make it where it attracts too, if you turn it around. All right, so the answer would be yes, but explain what kinds of energy you can associate with the spinning bar. So put your answer down there. And this is the final video of 1.6. This was your circuit of inquiries. So go through your notebook, make sure you have everything with an answer. Go back and look at all of your student sheets. That will tell you the questions for everything in your notebook. So a lot of the videos you didn't have the handouts visible like you see here. So just look beside the video and you will see the handouts. Well guys, it's been fun. I'll see you again in the next video for 2.1, the force of gravity.